I programmed the hub here to use that face tracking data to follow a face. So let's see how that works. If I move left or right, the camera follows my face. It recognizes my face. I can go up and down. Hey guys, Anton here from Anton's Mindstorms hacks. This is not a tutorial, but just a quick update on a project that I've been working on. I have a camera module here. It's an OpenMV camera, and I've been working on connecting that camera with a Mindstorms or a Spike Prime hub. And for this, I produced a breakout board here. So that's pretty awesome. I'm pretty proud of that. And it can connect the EV3 and spike cables here. It can even do cross spike UART or EV3 to spike UART. But in this video, I'm going to show you how it connects to the OpenMV camera and what you can do with it then. So it just fits the OpenMV camera. It's got exactly the right spacing here, and then I have this cable. It's an aftermarket Wedo 2.0 cable that I found somewhere. I think you can also cut off an old sensor and then crimp this kind of 6-pin connector to it. It's a 0.1 inch distance, and you can just then connect it to the breakout board here and then put it in a Spike Prime or Mindstorms port, like here. And this breakout board here, it feeds the 3.3 volt from the hub to the camera, so the camera powers on and then sets up a UART link. So let's have a look at how that works. I created a little program on the camera that does face tracking. So, and then I programmed the hub here to use that face tracking data to follow a face. So let's see how that works. Going to put it here on my desk and then start it up. And now you can see that you can't see the lights on the camera, but if I move left or right, the camera follows my face. It recognizes my face. I can go up and down. It just follows it. So that's pretty awesome. Inside this camera, there is a neural network that does face recognition over the pixels in here, and then it sees the location of the face in the picture frame and sends that location to the Spike, and Spike uses that to run motors here. And I'm actually pretty amazed at how well this reacts and how fast this face recognition is. So you can see moving up or down or left or right, this thing keeps tracking my face. I'm not sure if you can from the camera see how impressive that is, but from my point of view, I have this camera here always pointing in my face. So that's pretty awesome use of this camera. Also a simple demonstration, but there is more going on here, so I'm going to stop that program. The cool thing about this camera is that it is not only a camera, it also has some I2C pins here. So this Spike hub, it cannot really do I2C very well. There is no hardware I2C inside. I've seen some libraries to do software I2C, but I haven't got them to work. So this hub basically does GPIO, so programmable pins and UART. And to use I2C, we can use the processor here on the camera board. So I made a little demonstration here with this sensor is a time of flight distance sensor. It's actually a sensor that I hoped that LEGO would use instead of this ultrasonic sensor, because this guy here is smaller, faster, more accurate. But hey, ultrasonic it is. So I'm going to use I2C to use this sensor. This sensor is also really cheap. It's just a few euros, and there's awesome technology inside. So let's connect it here to I2C. You can see that the breakout board here that I built has got 4 I2C pins that you can easily connect to, and it also has pinholes, so you can solder a Grove board on that. So the choice is really up to you. In this case, I chose to use just 0.1 inch headers that work on most sensors. So now the I2C here is connected, and let's have a look at what that does. I'm going to connect via Bluetooth here on the Mac. It takes a while. It's a good moment to subscribe, by the way. So if you like these kind of technology updates, for now it's just a demo, but I plan to do a full tutorial and code release on how to do this. Is just a quick update of what I'm working on. Okay, now the Spike Prime Hub is connected to my Mac. So all of what I'm doing here with Spike Prime can also be done with the new Mindstorms Robot Inventor, no problem. I just had this one laying around. And let's open the tray here, and I created this program that reads both the time of flight distance sensor and the ultrasonic sensor, so we can have a look at the difference here. Okay, program is running. Now what you can see here is that I'm just going to use this tea can here as a distance measure. You can see that the time of flight sensor does need about 20 centimeter distance, unless I of course put my hand in there, and also the ultrasonic sensor does that distance. And on hard objects they are pretty much the same, but if I, for instance, try and measure the distance to my t-shirt here, that's a soft object, and the ultrasonic sensor has way more difficulties with that. So you can see on the screen that it flips to 200 centimeters from time to time, while the time of flight ranging sensor here neatly keeps reporting about 40 centimeters, which is the distance that I'm away from the sensor. So I think this time of flight sensor performs much better than the ultrasonic sensor in soft situation. Also, it has in corners, when there are, the ultrasonic sensor can show echoes. The laser beam is much more focused, and it's a much tighter report of the distance. Okay, so let's stop this program here. I hope you enjoyed this update of my hacking projects on Anton's Mindstorms X. Remember to subscribe if you're curious to see how this project evolves, if you want to see a tutorial about it, and I'm looking forward to all your questions in the comments, and see you in the next video. Bye bye.